In the previous lessons, we learned how to use this stoichiometry flowchart. That is how we always looking at the given unit, what's given to us, and we convert it or solve for the unknown unit. And we know that the box are where we start, and the arrows are the conversion factor that we had to multiply. But we only focus on this size of the flowchart. That is because we are working with one chemicals only. We're trying to solve from grams of chemical A, like sodium chloride, and determine how many moles of sodium chloride if we are given a specific amount. But now you have learned how to use chemical equation that describe a process of when we have reactant make product. So if we have reactants, okay, which is the raw materials that we are starting in our chemical reaction, and we mix them together to make our product, which will be completely different chemicals. So now we have multiple substances in the process versus just looking at one. So when we do that, we can now exchange from one chemical to another chemical. That being said, if I were to have a specific amount of this chemical, how much am I going to make of this chemical? So that's what's happening in this lesson. If you look at this one, we remember that the letter A represents one chemical, but over here we have the letter B, of course, is going to represent another chemical. So keep the chemical formula in mind. If they are the same chemical, we stay on this side only. But if now we involve two different chemicals, we have to go from this side somehow, going across over to this side. So be careful with that. Let's look at the problem together. So here I have a balanced chemical equation. And how do I know? I have 2 Na here, 2 Na here, 1 C here, 1 C there. And how many O? I have 3 O here, and I have 3 O there. And 1 Ca and 1 Ca. 2 chlorine, and there are of course 2 chlorine as well. So they are already balanced. And if you notice, there isn't any number in front of that chemical formula. And we of course know that it is okay to assume that it has to be 1. Because anything multiplied by 1 is equal to itself. So again, we have the reactant combined together to make completely new compound called the products. So in this case, this description here describes this chemical reaction. So to make chalk, the chalk that you write with, okay, those chalk. The chemical formula for chalk is calcium carbonate, CaCO3. Now to make chalk, which is right here, right, calcium carbonate, this is your chalk. Okay, and notice it is a solid. We dilute soluble compound, sodium carbonate, okay, and sodium carbonate look like this. See that? That's sodium carbonate right here. And of course, we're going to dissolve this in the water. And we also do the same thing to calcium chloride, and calcium chloride look like this. Okay, it doesn't look like chalk at all. So once we dissolve in the water, and notice we have the word soluble. What does soluble mean? Soluble means it dissolves in water. Then we mix the two solutions together to react sodium carbonate and calcium chloride to form soluble table salt. Table salt, remember the table salt that you eat at home, you make soup with it, right? It dissolves in water. So that's what soluble is. It disappears in water because it's being dissolved by water. And also it's forming chalk. And chalk, which is calcium carbonate, is insoluble. What does that mean? It doesn't dissolve in water. For example, I have water here. Look at this right here. See this plastic substance here? Does it dissolve in water? No, right? And to some extent, that's a little bit exaggerating. Let me bring something very familiar to you. That is something that you are already familiar with, and it doesn't dissolve in water. For example, I have copper here, right? Notice how the copper, the size of this copper shot is about the size of one of the calcium chloride. So when I put in water, what happened? Can you still see the copper? It's still there, right? It doesn't get dissolved. So we call those insoluble. It doesn't get dissolved by water. Where on the other hand, if I were to, let's put this aside first, dry this up a little bit. On the other hand, if I were to put calcium chloride in, look what happened, okay? See how it's forming bubbles, right? And if I were to stir this, and if you notice, you no longer see the solid particles of calcium chloride because it is being dissolved by water. So that is the definition of soluble. Soluble means that a substance can be dissolved in water. And now you have soluble substance. Okay. Another substance that's soluble that we mentioned in the problem is sodium carbonate. And look at sodium carbonate. Look like that, okay? And let's put in water. Look what happened when I put in water. Okay, do you see it? And look what happened when I stir it. You see how the sodium carbonate is being dissolved by water the more I stir it. And you can see that now we have a solution of sodium carbonate and a solution of calcium chloride. So that's the definition of soluble, okay? And not all substances in this world are soluble. Most of them are soluble, but not all of them are soluble, just like copper. So let's get back to our problem. So if we have sodium chloride as your product, which is we know is soluble, we're not going to see it because it's being dissolved. Where chalk calcium carbonate is insoluble, okay? So this insoluble, that means it's going to stay as a solid. And this solid is also known as a precipitate. So precipitate is another word for solid form in a solution. So precipitate, solid form in a solution. So that is the process of this reaction where we are going to make chalk. Now let's solve this problem, and how does that relate to the stoichiometry flowchart? So we look at this question right here. Using your stoichiometry flowchart, which is this one right here, okay? Determine how many grams of chalk, which is represented by calcium carbonate, this chemical here, and of course we are given the molar mass of 100 grams per mole. Okay, will be produced from 35 grams. Notice how will be produced from 35 grams of calcium chloride. This asks for you how many, right? Which is, we don't know. But this one is giving us 35 grams of calcium chloride. And it gives us the molar mass of 111 grams per mole. React with excess amount of sodium carbonate. Notice the word excess. What does the word excess mean? When you have an excess of something, like water, you have a lot of it. In a chemical reaction, the one that's not excess, which is the one that has very few of, will determine how much of that product being made, which makes sense. If you are to make anything like baking, you have a bunch of water, right? The amount of water is not going to determine how much bread you're going to make, but it's the limited amount of flour or sugar or salt. That's what determines how much bread you're going to make. So keep in mind, when you see the word excess amount of something, you can just ignore it because it won't determine how much product you're going to make. Now let's get back to this problem. We know that we are looking for question mark, which is our question mark, grams of CaCO3, okay? But we are given produced from, that means you're starting from, which is your 35, or you're given, in this case, 35.0 gram of calcium chloride. See how that works? And we can ignore the excess. So notice how the chemical is completely different, right? Our given chemical is calcium chloride, our unknown chemical is calcium carbonate. So we cannot just stay on this side of the flowchart, so we have to go from that side. But where do we start? We always start from your given, which is always on side A, okay? So we start on side A. If we start on side A, where do we really start? From G. What is G? G is your gram, and that is represented by, right, this box, okay? So we always start in the box. Why don't we start on side B? Because B is our product. So it doesn't matter, but always start on side A to keep it consistent. So this is where we start. I'm going to label that. Why we start with there? Because that's the grams right there. So grams of A. So we start there at that box. And where do we end? Now the chemical is calcium chloride, which is completely different than our chemical also given. So we know that we need to end somewhere in grams, and specifically in the side B. So on side B, this is the only place where we have grams. So this is where we end because we are looking for grams. You see the unit where is grams. So it's extremely important. We have B, that's because two different chemicals. So let's go back and use our stoichiometry flowchart. So to start from here to end to there, we cannot go over here directly. It doesn't work like that. So we follow the arrow on the flowchart. So we have to go down, across, and up, right? So going down, we have our first conversion factor right there. Then after we go down, what do we go next? We go across. So that is our second conversion factor right there. But we're not there yet, right? We always end at the unknown, which is B, grams of B right there. And then we go up. Voila. And that is our third conversion factor. Isn't that crazy? So we start from here, followed by the flowchart, and going down, across, and back. And this is the order of conversion factor that your given will multiply by. First this one, second, and third until you get that part right there. Now let's set up this problem together. How about that? Flowchart. And now let's go back to our stoichiometry flowchart to show it work. Of course, we always start from your given, okay? So we are given, okay, we are looking for what? We are looking for a question mark. What are we looking for? We're looking for question mark grams of CaCO3, okay? And then what are we looking for? So we are looking for grams of calcium carbonate, which is right there. But what are we starting from? We are starting from our given, which is 35 grams of CaCl2. That is our grams of A right there. We start right there. You see that? And we're going to grams of B is on that side. So you get from here to there, we're going down, across, and up. So let's go down. We multiply by that conversion factor, which is equal to 1 moles of A, and I know what A is going to be, which is calcium chloride, okay, CaCl2, and that's equal to number of grams of A. And what is the name of this conversion factor? It's called molar mass. Do we know the molar mass of CaCl2? Yes, it's given to us. It is 111 grams per mole. So we have the mole over here, which is right there, and now 111 grams of CaCl2. So we are done with that conversion factor. Now let's move on to the second conversion factor. This is where it gets tricky. Are you ready? So the second conversion factor, we have never used this conversion factor before. But all the conversion factor on this side and that side are exactly the same except for A and B. Except for this one right here. This conversion factor is called mole ratio. So what is a mole ratio? So mole ratio, think of the name, mole ratio. So it's a ratio between moles, right? And the way it works like this. You have a number of moles A equal to number of moles B. So chemical A equal to chemical B, but in terms of mole. But where do we get that number of moles from? There are two places. First is the coefficient number, okay? That number right there is the coefficient number, or the subscript number. We talk about the subscript number later. But for now, the coefficient number, where do we get that from? Well, that is coming from the balanced chemical equation that we just worked. See right there? Notice how our A is right here, which is calcium chloride, and our B is calcium carbonate. Look at the coefficient. Here we have coefficient 1, and here we have coefficient 1. Oh, beautiful. So we just have 1-to-1 ratio. So what does that mean? So that tells us all we have to do is this. Remember the coefficient is 1, right? So we have the number of moles A. Let's write that down. And the number of mole A, we know exactly what A is. In this case is calcium chloride equal to the number of mole B. And do we know what B is? Of course, is what we're looking for, calcium carbonate, okay? So go back to the balanced chemical equation. It has to be balanced. And look at calcium chloride. What's the coefficient? Oh, it's 1. There you go. See right there, it's 1. And look at calcium carbonate. What's the coefficient? Oh, it's 1. So that's also 1 as well. If it's something else, it will be something else. Okay? So keep that in mind. This is the coefficient. And that's how you use this mole ratio conversion factor. Now we move on to the next one. And notice how it is the same as that one over there. So all we have to do is this. Okay, times by that conversion factor, which is 1 moles of B. And we know what B is in this case. We know B is what we're looking for here. And this is our A. Okay, B is calcium carbonate. So CaCO3. And it's equal to number of grams of calcium, number of grams of B, which we know is calcium carbonate. It's the same process. See how that's the molar mass of B. That's just because we deal with different chemicals. And what's the molar mass of calcium carbonate? It is given to us right here 100 grams of calcium carbonate per moles of calcium carbonate. So we have 100 grams of CaCO3. And then are we done? Yes, because we finally stopped where we need to stop, which is the end right there. So we're going down across an end, and this is where it gets tricky, okay? And the rest is extremely easy. You just need to rewrite this as fraction, and then you are done. So of course I have 35.0 grams of CaCl2 time, okay? That conversion factor, notice this is gram of CaCl2, so we look at this conversion factor only. We have mole and gram. We need to cancel the gram, so the gram's gonna be on the bottom, along with the number of gram right there. Gram of CaCl2, okay? Of course on top would be 1 mole of CaCl2, because we have nowhere else to put it. And gram of CaCl2 cancel out. Now we move on to the second conversion factor, which is this one right here, isn't it? Notice how we both have mole, right? So the unit itself is not enough. Now we have the chemical. We have moles of CaCl2. Over here, we're looking at the conversion factor. We have moles of CaCl2, then we have moles of calcium carbonate. So we need to cancel out calcium chloride so we can solve our calcium carbonate. Of course, this part is going to be in the bottom. How many mole? Based on a balance coefficient, right there, it's 1. So it's 1 mole of calcium carbonate. So 1 mole of calcium chloride. And this on the bottom, so this part must be on the top, which is also 1 mole of calcium carbonate. And remember, this 1 is your coefficient, okay? Notice how moles of calcium chloride cancel out. Give us a carbonate. That's exactly what I'm looking for, right? Now this conversion factor is done. Now let's move on to the next conversion factor, which is this one. And now we're no longer dealing with calcium chloride, but we focus on calcium carbonate. That's the beauty of this flowchart. Once we use this conversion factor, we have changed our focus from one chemical to another chemical. But this connection allows us to change one chemical to another chemical using the unit mole. And that's the reason why we always count everything in moles rather than in atoms, okay? That's the beauty behind the unit moles, is allow us to connect one chemical to another chemical. Now let's go back to this. If this is moles of calcium carbonate, if we look at this conversion factor, moles of calcium carbonate will be on the bottom as well. So we have 1 mole of calcium carbonate. If this is on the bottom, top part would be a leftover, which is 100 grams. That's the molar mass of calcium carbonate that we use, okay? CaCO3. And that cancel out. And the rest is pretty easy. We just multiply everything on top, divide everything on bottom, which on top is 35.0 time, nothing there, right? We ignore the 1, time 100, okay, in grams of calcium carbonate. Divide everything on the bottom, which is 101, which is 111, time 1, so we ignore those, and that is our answer. And notice how we have grams of calcium carbonate, which is exactly what we're looking for, okay? See how that works? Beautiful, isn't it? So now let's plug this into our calculator. Isn't this easy? Let's plug it into a calculator. Now 35.0 times 100 divided by, multiply everything on top, and you just divide everything on the bottom, divided by 111. Give us 31 grams of. So if you have 35 grams of calcium chloride and treat with excess amount of sodium carbonate, you would produce 31.53 grams of calcium carbonate of chalk. So this is what we are looking for, okay? See how that works. Now let's prove it to you. What happened when I mix them together? Okay, when I mix them together. See how this are two solutions, right? So what happened when I mix them together? Are you ready? So know how clear the solution is. It's kind of cloudy because it's not all completely dissolved. But look what happened. Are you ready? I have an empty flask right here. This flask is empty, right? So I'm going to pour this solution in first. Right there. One of the solution is calcium carbonate. So we're going to pour the solution in first, okay? And notice how it's clear, right? And then I'm going to mix in solution. I want you to observe what happened. Look what happened. Do you see that right there? Look at that. That is the solid precipitate. Look at the solid. Look how much solid is forming in that case. And this is chalk. This is the chalk that we just produced right now. Look at that solid, right? We can see that cloudiness. That's the solid. If I turn my beaker around, you can see that that solid kind of stuck in there in the beaker. If I continue to add more, of course, it becomes more solidified. Now you have more solid. And you can actually filter this out and you will collect your 100% calcium carbonate chalk. And that's the same chalk that you use in class. Beautiful, isn't it?